Hi guys, so this is the second update video. So first I will discuss the watch, then I will go to the mutantC. So here you can see I soldered everything. This is the buzzer and there was a wrong connection with the register, so I had to fix it using a Bosch register here. So this is the ESP32C3. Yes, this is the two button. I didn't solder the accelerometer and the battery voltage monitor chip because I don't have them yet. So when I will have them, I will solder them and test them. But first test was the consumption of the ESP32C3 with the whole system here. Not actually whole system, like the display and the working. So what I'm trying to achieve is less power consumption. So what I'm doing in the code is when the device or the display is active, the chip is running 80 megahertz with the Wi-Fi, and when the display is turned off after 10 seconds or 6 seconds, the chip goes to 10 megahertz. So it will hopefully reduce the power consumption when it's not inactive. So you may guys suggest to do the deep sleep, and when a button is uh, clicked, then wake up from the deep sleep and do the thing you want to do with the watch. But the thing is, C3 don't have a function where you can wake up the C3 using the button click or external way. But only thing you can do to wake up from the sleep is like you set a timer inside, and when the timer goes off, the ESP32 wakes up and do whatever you want and go to sleep again. But that won't work here with our watch. Suppose you set a timer and it went to deep sleep for 6 seconds, then wake up for 10 seconds, then goes to sleep again. But when it sleep, you can't see the time, so that's not practical for what we are trying to achieve here. So that's not an option, the deep sleep. And you also may suggest use ESP32 only, the older one, or the newer one, S3 or S2. But the thing is, it won't fit here with the other components. That's the one major issue. And the second one is, if we use the S3, when it's active, like when you are using an S3, the power consumption is much larger than the C3. That's one thing. And another thing is, like, those chips are also a little bit expensive, and uh, the deep sleep will supposed to work fine, but I wanted to make a cheaper one. In future, maybe hopefully we will use the bare chip, not with the like this module. That will help us to use the S3 in this small PCB. But the thing is, like, then it will be more harder to build because you can't solder those chips, the small chips, using your iron. You need a heating plate and other like it will be really complicated to solder or build this uh, watch like the PCB. So that's another reason I'm not using a bare chip, only the chip. Also, they needs like lots of components to work. They can't they really need like lots of different kinds of component. But with the module, you just solder the module. It's easy to solder. But hopefully in the version 2 I will achieve minimum power consumption that will give us at least 6 to 8 hours of battery life. But in the future I'm thinking like using a bare chip, because here you can see the battery monitor chip. It's tiny, you have to solder it. I can solder it with my soldering iron. Actually it will be really harder than the first version to build the second version, because this voltage chip and this accelerometer chip, uh, you need to have like a really good soldering skill to solder those. So as we are using these two chip here, bare chip, so I'm thinking in the version 3 maybe I will use a bare chip with a S3 maybe, or hopefully the newer one when it comes out. So here you can see when the chip is running at 10 megahertz, the power consumption is zero point 0.4 amp, 0.04 amp. When the display is turned on, the chip will run at 80 megahertz. So the power consumption, you can see it goes to 0.08 amps. So the battery we will be using is this. Here you can see it's 200 milliamp hour. So when it's running at 10 megahertz, the watch, so it will consume around 0.04 milliamp hour. So it goes to around 5 hours idle time. That's really good. That's a really good improvement. We can use a bigger battery also. There is a space for it in the new version, because I relocated the pins for docking station. So I think we will get around 6 to 7 hours if we are using a 250 milliamp hour battery. And another improvement we can do is the voltage chip here. The that chip which is converting the 4.7 volt to 3.3 volt to use. I searched through the internet. The chip I'm using, it's not really good at low power stuff. What we are doing here, I think when the chip ESP32C3 is running at idle, it should consume around 0.02 milliamp hour, but it's consuming 0.04 milliamp hour. So I think it's because of the chip we are using for the voltage conversion. So I think I have to find a new chip which will be much more efficient, converting 4.2 volts to 3.3 volts. Yeah, so I'm looking forward to that. I will soon order the chip that I need, the accelerometer and the voltage monitor chip, and also a new voltage converter chip that will lower the consumption that it's supposed to have. Right now I think the minimum power consumption when it's running at 10 megahertz should be around 0.02 milliamp or 0.03 milliamp, not 0.04 milliamp hour. I know it looks like really small amount of power, but the thing is with this small battery, uh, we need to think about the power consumption really well, because at the final target is we want a watch that will last for at least a day and more than a day. So but the thing is with that achievement, the whole build will be complicated. We need to use really hot plate to solder the things, because we can't use a soldering iron anymore. Yeah, so now we'll go to the mutantC version 5. Today's sponsor is PCBway. They have PCB printing services starting from $5. You can order 10 PCBs in 9 different colors here. They also have 3D printing service which is very reasonable. Go to the third section of the website and click 3D printing service and add your own STL file. Choose materials and other features and get a price. Check out their 3D printing service and PCB printing service from the video description below. So with the version 5 PCB I didn't did much. I just soldered the MT306 to convert the 5 volt to 10 volt, but the chip I used it from another module. I just desoldered it. I think the chip is not good. I think it's broken, so we are not getting from 5 volt to 10 volt here. The chip heats up, so I need to order new chip, and also the inductor is not correct, so it should be 220 but it's 300 because I desoldered all the things from the, not all the things actually, the chip and the inductor from the module we can buy from the internet. Yeah, so not much update in the version 5 PCB. So another thing I didn't share last time is how large the PCB. Yeah, it's large, but the function it have, it's worth it to make the PCB large. uh, so we can see the dimensions. I know it doesn't fit, so it goes around 16 centimeter in this length and around 87 millimeter in the width. So hopefully it won't feel when the everything is all together, it won't feel that big, but right now it looks big. Yeah, I know. And another thing I forgot to show you is the buttons here. 11 in this way and 5 is this way, again 55. Buttons here is also buttons, and what I'm trying to do is, you can see here these small parts here, those are the LEDs. So hopefully we can get a backlight out of this new version, because I heard so many complaints about the keyboard. So in the version 5 hopefully the keyboard will look good and feel good, and hopefully it will be also backlight. Yeah, so when I get the chips, and I will do the next update with the new chip for the power and also for the mutantW. Hopefully I will see you in next video. Thanks.